Kia ora, hello folks. I'd like to talk to you about concave mirrors, how to find an image when the distance to the object is less than the focal length. First of all, I'd like to look at three symbols, two of them new, I've inferred that. How to make a ray diagram for the distance to the object is less than the focal length, and how to find the nature of the image, which we'll call NOI, the distance to the object is less than the focal length. The focal length is something we're familiar with. That's just lowercase f. It's different from capital F, which is the position of the focal point. We've got d subscript O for distance of the object, and it's d, O, and no surprises. Distance of the image from the mirror is do, do, and di. They're often pronounced do and di for efficiency, and I will do that. For do less than f, and the concave mirror, which means the focal length is positive. If I put in the principal axis, then draw the location of the mirror, then draw the mirror. However, for efficiency, we don't tend to bother drawing the whole mirror. We just draw a little wee cusp in the middle to show that it's a concave mirror, and we assume that this whole big straight line down here, which is where the mirror is actually the mirror. We draw in the focal point and the center of curvature. If we then draw in the object, which I'm going to put in as roughly halfway between the focal point and the pole, draw in these distances, do, f, and r. If I bring in a ray that's parallel and send it out through the focus, that makes sense for these things. Then bring another ray into the pole. It will then come out at the same angle. And where these two rays join up again, because they started together, where they finish up together, we will form an image, a real image. They're not going to join up together again, we won't get a real image. So we then try for a virtual. So any real image? Nope. Absolutely nope. So we'll check for a virtual image and get rid of those bits of writing and continue one of the rays back. And we then put an eyeball, also put an eyeball down here, because we'll be looking up in here for a virtual image. Continue the other ray back. Where they cross is where our brain and our eyeball combined think that, because light tends to travel in straight lines, we will think that an image started here, and we'll draw it in. We use an arrow because it's easy to draw. There's a definite top, definite bottom, definite distance from the mirror, and a definite height. Very quick and easy thing to draw. We'll have a virtual image here, and the nature of the image will be virtual because the light rays do not actually go there. Real images, light rays go there. Virtual images, light rays do not actually go there. It will be upright and it will be magnified, and that's what we understand to be the case. And a good example is a shaving mirror. Cheers everybody, I hope this has been useful to you.